Okay, so this is the Junior Cert Higher Level Maths paper for 2022. And we're going to have a look at questions 5, 6 and 7. So in question 5 we have a balloon pump and it's made from a cylinder with an internal diameter of 6 centimeters and a height of 20 centimeters as shown. Each time the pump is pumped, it passes one full cylinder of air into a balloon. Show that the volume of one full cylinder of air is 180 pi cubic centimeters. Okay, so the volume of a cylinder is really what we're looking for here. So the volume of a cylinder is pi r squared h. So that is pi. We need the answer in terms of pi, so I'm just going to leave pi there. We're going to take the radius, which is 3, and we've got to square that, and then multiply by the height, which is 20. So let's see, we've got 3 3s are 9 and 2 9s 18, so it's 180 pi centimeters cubed. Okay, so we've done that. Okay, so let's look at the next part then, part B. Dara is inflating a balloon in the shape of a sphere. So we're given a diagram of that. I haven't got it here, but there is a diagram of a balloon in the shape of a sphere. So you can imagine the sphere here. And we're given the radius, which is 15 centimeters. So this is our balloon. Find the volume of Dara's balloon when it is fully inflated. Give your answer in centimeters cubed. So this time we're just looking for the volume of a sphere. So again, all these formula are in your tables. 4 over 3 pi r cubed. So we've got 4 over 3. Again, in terms of pi, it's just going to be times pi. And we've got to multiply by the radius, which is 15, which we've got to cube. So when you do all of that, you get 4,500 times pi, and this again is in centimeters cubed. Okay, so let's look at part 2. Dara pumps the pump once every second. How many seconds will it take Dara to fully inflate his balloon? Okay, so each cylinder volume is 180 pi. We need 4,500 pi centimeter cubes to fill the balloon. So it's just going to be 4,500 pi divided by the 180 pi. So the pi's will cancel there, or you'll get 1. And from that you will get 25 seconds. Okay, next part then. Gustav is inflating a bigger balloon in the shape of a sphere. So again, we've got a bigger balloon this time in the shape of a sphere, which has a certain radius. And we've actually got to find this radius in this question. He also pumps the pump once every second. His balloon is fully inflated after 50 seconds. So that means each cylinder pump is 180 pi cubic centimeters. He's going to do this 50 times, so we've got to multiply that by 50. So that gives us that will actually give us the volume of this bigger sphere. So if we do that, 50 times 180 is 9,000. So we're actually going to get 9,000 pi centimeters cubed. That's the volume of this particular sphere here. So we now know that 9,000 pi is equal to 4 over 3 pi r cubed. This is the volume of any sphere. This is the volume of our sphere. So we can work out what r is here. So we can see here that we can divide both sides by pi. So that'll give me 9,000 is equal to 4 over 3 r cubed. I'm going to multiply across by 3 because I have a 3 on the bottom here. 3 9s 27,000 is equal to 4 r cubed. And let's see where we are now. We've got, we've got to divide by 4 now. So 27,000 divided by 4 is 6,750. That gives us r cubed. And then finally, we just got to cube root both sides. So the cubed root of 6,750 is 18.9, and that's in centimeters. And that's to 1 decimal place, I think we had to do here. Find the radius of Gustav's balloon when it is fully inflated. Give your answer correct to 1 decimal place. Okay, so that's that one done. Let's have a look at question 6 then. Okay, so 80 students in a group were asked what they had done during their summer holidays. Some of the students got a job, some went on holidays, and some did both, some did neither. 1/5 of the students in the group did neither. 25% of the students got a job. Of those who got a job, half also went on holidays. Work out the total number of students in the group who went on holidays. You may use a Venn diagram below to help you answer the question. So this is what we've got to do here. Okay, so let's start. Now we're told that 80 students were in the group in total. 1/5 of the students in the group did neither. So what we've got to do really is just get 1/5 of 80, and that will give us the number who did neither, and that's 16. So we're going to get 16 out here. So we should put 16 out here somewhere. Now 25% of the students got a job, so let's have a look at that then. We've got 25% of 80, so that's a quarter of 80, so if we do that we'll get 20. So that means 20 will appear in this part of the graph here. So I don't know where that's going to go, how we're going to split that up. So let me just put 20 here for the moment in brackets. Who got a job. Let's see if it gives us any more information on that. Of those who got a job, half went on holidays. So half of this 20 went on holidays. So that's 10 in there, so the other 10 must be here. So that's perfect. Now remember, in this type of Venn diagram we have 4 sections. We filled out 3 of them, so we'd be able to work out this part here because we know that there was a total of 80 students. So if you take 10 plus 10 plus 16, subtract from 80, you'll get 44. So now we have the diagram filled in fully. What do we actually have to answer? Let's see, work out the total number of students in the group who went on holiday. Well, the total number of students who went on holiday, this amount here, 44 plus 10, which is 54. So our answer then, you're given space in the answer booklet for it, but the answer is 44 plus 10, which is 54 students. Okay, and that's it for this part of the question. Let's have a look at, oh, there isn't another part, that's fine. Oh, we're given the place to put in the answer here, so it's 54 in here, perfect. Let's have a look at question 7. Okay, question 7. Amy and Joe are asked to pick values for the numbers p, q, and r so that the following is true for all a is an element of r, a is real in other words. So look what we have here. We have a to the power of p times a to the power of q times a to the power of r is equal to a to the power of 12. Now this is a question based on the laws or the rules around indices. When you're multiplying these things here with the same base, so we have an A, an A, and an A, what you do is you add the powers. So in other words, if we add P, add Q, and add R, we should get 12. So Amy picks 3 values that were all the same, so that P, Q, and R have to be the same. Write down the values of P, Q, and R that Amy has picked. Well, it has to be 4, 4, 4, and 4. 3 fours will give us 12 when we add them. Perfect. Joe picked 3 values that were all different. Write down possible values for P, Q, and R that Joe might have picked. Well, you can pick any 3 numbers that will add up to 12. So let's say 2, let's pick a 6, that'll give me 8, and then this one will have to be 4 here. Okay, so let's have a look at part B then. So find the value of M so that the following is true for all B is an element of R. Okay, so we have b to the power of m times b to the power of minus 2 divided by b to the power of 1, in fact, is equal to b to the power of 10. So let's simplify the left-hand side. If we look at the top here, we have the same base, b and b. So what do we do with the 2 powers? We add the 2 powers. So that just simplifies to b to the power of m plus minus 2, which is minus 2, divided by b to the power of 1, and that's equal to b to the power of 10. Right, so we have a b to the power of something divided by b to the power of something, so what do we do to the 2 powers? We subtract them. So this is equal to b to the power of m minus 2 minus 1 is equal to b to the power of 10. This will give us b to the power of m minus 3 is equal to b to the power of 10. Now when you have b to the power of something equals b to the power of something, that just means that the two powers are equal. So that means m minus 3 is equal to 10. So finally then if we add 3 to both sides, that gives us m is equal to 13. Okay, and that's it for this question, question 7.